Right, you are all welcome to this event that is going to discuss machine learning application, okay, in financial trading and investment. So this is part of our AI application in finance workshops, which we started from 1st of January up to today. We are still doing the workshop, and we intend to do this workshop throughout the month of January. We are seeing different applications of AI. We are building different systems that will be able to enhance and support our trading activities as well as investment strategies. So, as a disclaimer, what we're going to discuss is basically for educational purposes, and it's not a financial advice. So, for those seeking an advice, I will advise them to also seek that from an expert financial advisor. So the agenda, we will start with an introduction, then I will discuss some little bit about machine learning. So I will give an overview of machine learning. After that, there will be a case study, which I will show you some examples of machine learning usage in real life and as well as in the trading and investment arena. We will see how we will develop a strategy that uses AI, okay? And then this strategy, we are going to follow a framework to build it so that you will have a trading bot that will be doing everything for us. Once we have this framework understood, we are going to now use this framework to build the trading bot. Lastly, we will have a quick discussion and quick question and answer session. So welcome once again. I am your host and the presenter, Abubakar San Ali. A little bit about me. I did my PhD in electrical and computer engineering from Khalifa University in the United Arab Emirates. Before then, I did my MSc in communications and signal processing from University of Leeds in the UK. My major during bachelor's is electrical engineering. So I have had different activities, projects, and programs that cover things that had to do with applications of AI in different sectors, starting from telecoms, electrical power, down to financial aspects of trading, for example. The host institution is called Asatora Services, and it is a company registered in the United Arab Emirates that provides consultancy in the areas of AI, Internet of Things, and cybersecurity. It also provides training and workshops, and this is one of those workshops that we provide. And then lastly, we do lots of works related to research and development. So while I start this, I would like to say, if you have a question during the session, okay, you do not have to hold on. You can just raise up your hand and ask your question right away. And why that is the case is because maybe if we delay your question, you might forget the question, or you might become more confused with the additional concepts and contents you're going to see. So if you have a question, just use the raise hand button and raise hand, and I will do my best to respond to your question ASAP. So what do we intend to get out of this workshop? Okay, first of all, we want to understand the basics of machine learning and how it is used in the arena of trading and investing. We are going to see some case studies that use machine learning to improve success rates, and we are going to build a trading bot, okay, which is going to use linear regression model, which is one of the fundamental machine learning algorithms. So when we talk about trading, we have three components mostly, starting with the strategy. These are the set of rules upon which we follow to first of all identify a trading opportunity, and then based on the identification, we might follow some rule or strategy to get into the trade and also well as get out of the trade. So basically, this is where AI helps a lot. Not only that, the psychology aspect, this has to do with our emotional state and psychological state when we are making trades. Okay. So our mindset helps us a lot in determining our profitability in the investing arena as well as the trading arena. So if we have robots that do not have emotions, that significantly improve our chances in the financial market. Management, this involves things that have to do with how we manage our capital, how we manage our resources, so as not to lose our money while uh, trading or investing in the financial market. So in that regard, where did algorithmic trading comes into play? So when we say algorithmic trading, we are talking about systems that involve the usage of computers and computer algorithms to execute trades. They will make predictions based on the criteria you provide them with, for example, the time, the price, and the quantity. Not only that, we want them and they help us to make orders or execute orders at the best possible prices, thereby reducing the impact of human emotions during the trading activity. Some of the benefits include speed and efficiency. We can't compare with the computer in terms of speed. Not only that, consistency and discipline. Okay, they do not have emotions and they follow instructions, so we expect them to be consistent. And because of that, our risk management is going to be improved. To top it all, we have the backtesting capability. Humans cannot go back in time, but these trading bots can use historical data so that they improve themselves in terms of predictions and decision making. Scalability is the last or one of the most important benefits that is brought to us by these bots. And that is the case where we have, let's say, multiple bots monitoring different assets at the same time. Humans have that limited capability. We can't do much or many things and they go. But with the bots, we can have different bots, each one working on a different uh, asset, trying to help us profit from the market. So then we understand, okay, this is what algorithmic trading does. It makes our trades, it automates them, using computers and what have you. But then this era that we are in, AI and machine learning, how is it going to help us to improve our trading success rate? So to make some clarification, when we say AI and when we say machine learning, we are talking about two different things. Although we can assume machine learning to be a subset of AI. So whenever you hear people talk about AI, they are talking about the whole field, and machine learning is a specialized field within AI. So in AI, you have other fields, for example, evolutionary computation. All these are part of AI, the search algorithms and what have you. But then you have machine learning, which is a subset of AI. And this is a process or it's a system where we expect our computers or our programs to learn from experience. So we do not implicitly program these systems. We do not tell them when you see this, do this. No, we allow them to learn from experience. And by experience here, we mean data. So if we have historical data, we provide it to these systems and they look at the historical data and they try to develop a pattern. So they recognize a pattern within the data. Based on that, they program themselves by themselves. So we are not explicitly programming them. Okay, we just give them data to do that. And a subset of machine learning is called deep learning, and this is the type of machine learning which uses neural networks. So what we're going to see today was what we're going to see one tool, for example, a large language model, which you will talk to it and it should be able to respond to you. If you have a large language model powering a chatbot, then you can be able to see how powerful these tools can be. And this generation is done by deep learning algorithms. So this is what we are talking about when we say deep learning, machine learning, and AI. So there are subsets of one and then so on. Some of the applications of machine learning you are used to include email filtering. If you have your Google Gmail account and you open the Gmail account, you will see different folders, inbox, personalized. For example, you see promotions, you see social, you see spam or junk folder. So whenever an email is received in your account, the computer tries to classify which of these folders this email belong to, and this is email filtering. Okay, another application you are used to seeing is the speech recognition. We have Siri, we have Cortana, Google Voice, and all that. So we speak to them and they are able to understand our speech and respond to us accordingly. You have predictive analytics that is used to make prediction. Okay, for example, the predictive analytics can be used, in medicine, so that they predict when you need to take your next dosage and the amount of dosage you should take. In finance, for example, we can be able to predict the credit score. In retail stores, for example, they can have an idea of what customers need. And a good example of this is there was a case in Target where a lady was receiving pamphlets and flyers regarding, products, baby products, and pregnant women products. So when the father received the mail in the mailbox and he saw those flyers, he thought it to be inappropriate. He went to Target to complain to the manager. When he saw that why are they sending his teenage daughter these flyers, only for him to find out later that his daughter was actually pregnant. So even the algorithms in Target were able to predict the pregnancy of that daughter before even her family come to know about it. And because of this, so many actually policies were set up to avoid privacy issues. In 2018 and 12, Obama used Facebook, and what he did was he was using data mining approaches, where if one person follows Obama, he gets access. The team behind the Obama campaign gets access to that person's contacts, and they try to figure out among those friends of this person who is most likely going to vote for Obama. Then they bombard him with so many ads related to the Obama and what have you. Using this, Obama was able to do well in the poll. Now, machine learning has different tasks. Okay, we have three main tasks that machine learning does for us, and this is the most important part of this activity. Based on your understanding of this, you will be able to know what type of machine learning algorithm should you use for a particular problem. So given a problem, having an idea of this, you will now be able to make a decision that let's use this is the right algorithm and this is the wrong algorithm for this problem. So your problem will be the determining factor. So some problems, require data to train the algorithm or the model. So you can consider algorithm as a teaching methodology which a teacher uses, and then you can consider a model as the student that is being taught, and then the data, you can consider it as the examples or lecture notes provided by the teacher to the student so that you can be able to learn. All right, so in supervised learning approach, this is a process of, let's say, learning with a teacher. You have a teacher who is there, he gives you the lecture notes, he gives you the materials, and he shows you the examples, solves the examples for you on the board, and tells you this is the solution, this is the answer. You see this problem, this is how you solve it, this is the answer. So with this, you are able to map and model some patterns of that information so that if he comes and tests you with something in that domain, he taught you mathematics, let's say algebra class, he comes and gives you an algebra question, not necessarily has to do with the algebra examples we solved in the class, you should be able to solve it. That means you've understood the pattern of solving the algebra. So this is called supervised learning, and it comes in two shapes. We have what we call regression This is when we predict a numerical value, a continuous number. For example, you want to predict house price. You want to predict stock price. So this is a regression problem. You are predicting a continuous number. Stock price could be 10, 20, 21, 22.5, and so on. A continuous number. But then we have another type of supervised learning called the classification. This is where we predict categorical values, that is the labels, for example. So when we have images, so if we have an image of a cat, we want to be able to say this is a cat, this is a dog, this is a house, this is a rock, and so on. So this kind of prediction, where we try to categorize things based on this, we call a classification. All right. So, but as I said, this requires data. You need a data. You have to have an example. The person has to provide an example, tell you that this is the example. Okay. This is this image. This is
my father had the head, so I thought best to follow just.
Okay, this is an image of a cat. So you want to know this, for example. And in the case of unsupervised learning, here you have the teacher, but you have no idea. Okay, you do not have the teacher, you have only the data. So it's like having somebody who goes and looks for documents on his own, trying to sit and learn. Okay, so he doesn't know image of a cat, image of a dog, image of a lion. He doesn't know the name even cat. He doesn't even know that this object is called a lion. He doesn't. But from looking at them, he can be able to identify something, and he can be able to say, okay, I think there is a pattern here. When I see 4 squares with some here, entry, exit, and what have you, this is a house. So all the images that relate to a house, you will put it on one side, that is clustering, but he will try to look for associations and stuff like that. But nobody told him this is a house. He doesn't know also the name of that object, but he was able to identify that this belongs here, this belongs here. They are different. So this is an unsupervised learning approach. It comes in different shapes. The example I just gave is about clustering. He sees images and he tries to put them together, or he sees news articles, tries to put them together without even an idea that this is supposed to be a sports article, this is supposed to be, finance article, but it was able to categorize them accordingly. You have association, where you try to find, association between two things. Is this associated with this? We have prediction. We try to also similar to association to find how things are similar. You have data reduction. Here, this is important. It's what we call it dimensionality reduction. Let's say we are trying to predict the price of a house, okay? But then there are so many things involved. For example, we want to know the size of the house as well as the number of rooms. So somebody could tell you that the number of rooms in a house is a function of the size of the house. So the bigger the size, the more rooms you are expecting to see. Therefore, you can say, okay, in that case, let me drop one of these so that I don't get confused, and just focus on understanding what is the relationship between the size of the house and the price of the house. Instead of having the size as well as the number of rooms to be able to predict the price, I can just drop one of them so that I simplify my problem to just having only one predictor, and that is what we call dimensionality reduction. Reinforcement learning is a type of machine learning. So if you have a problem, all the previous ones require data. You need to have a data, and that data is used to train this model. And as I said, the model could be the student. Okay, so this is different. It's like having a student sitting, watching how things are done. But in reinforcement learning, you do not show him videos of how to ride a bicycle. You just give him the bicycle and you tell him go and figure out how to do that. So if you have a problem that you do not have data, but you can come up with a simulation environment. Why I say simulation environment is because we don't want to have things happening, accidents happening in real life. For example, let's say self-driving car. You do not want to have the car to learn how to drive on its own. We do not want to have that case. But if we have a simulator where we'll train the model in that simulation environment until when that simulation environment was able to give this model the ability to learn how to drive, as accurate as possible, then we feel safe and we come out to deploy it in the real world. So this is one limitation of reinforcement learning. You cannot deploy it in real world because you need to be able to avoid accidents, and sometimes you can't afford to do things by trial and error. So these are the three different types of machine learning. So whatever problem you have, try to map it into one of these. Is this problem a supervised learning or unsupervised learning? Or is it even a reinforcement learning? How do I know whether it is supervised or unsupervised? Do I have a data? Okay, I have historical data, fine. But do I have the levels to be able to tell? Okay, I have house pricing, we have the price list, we have the price, we know how much each house costs. Then I will do supervised learning. But then now the level, which is the target, which is what I'm trying to predict, that value, is it a continuous or is it categorical? Okay, so if it is continuous, I know this problem is regression. Okay, so with this, you can now be able to make decisions on the type of algorithm to use. And as I said, algorithm is like the teaching methodology you follow to teach the student, which of course is the model. So when you hear me say model, I'm talking about the student. Okay, and when it comes to trade, for example, it enhances our predictive accuracy. Not only that, it allows us to process large data sets. As a human being, you have limitation, your cognitive ability is limited, so you might not be able to process as much data as as your brain can due to so many constraints, but the computer can be able to process so many chunks of data at a go. Not only that, when you come to identify complex patterns, sometimes it might be difficult for us to understand those complex patterns, but the computers will keep at it until when they figure something out. All right, and it is used in financial trading in the sense, in cases of price prediction. We want to predict a price. That's something we will see. Risk management and compliance, algorithmic trading, and the likes. For traders, they use it to help them to have what we call data-driven decision making. So we want to use this historical information to help us make better decisions, and thereby reducing our emotional bias. Okay. Lastly, of course, it improve our trade execution speed. So in real life, there are 5 prominent examples of the usage of AI and machine learning in the financial world. One of those examples is the Renaissance Technologies, okay, by Jim Simmons. This company was started by Jim Simmons as a hedge fund. Okay, so Jim Simons is a professor of mathematics, and he brought in with him different guys from different fields, especially related to stochastic process, statistics, mathematics, and what have you, machine learning, quants, and what have you. They come and they were building models that were able to predict, and he is now titled the most profitable trader in history. BlackRock, this company, they own almost everything. Okay, they own almost everything. So they have a system called Aladdin that they use to identify good investment options. Okay, Stadel, this is also a bank for a hedge fund. They have what they call they have some robots that they use to carry out high frequency trading. But if I did not forget, they spent around $500 million to install a fiber that connects to the Nasdaq broker, the Nasdaq exchange, directly to their company, so that they will be getting information in nanoseconds. So because they are executing high frequency trading activities, so meaning that they go in and out, they buy and they sell in milliseconds. Okay. Charles Schwab, investment bankers, they have what they call robo-advisors that gives advice to people on how to invest their money. So personalized advice looks at your own financial situation and gives you an advice how to use your money appropriately. Okay. JP Morgan, investment bank as well, they have a system called LogZem, also for allowing them to do trading, equity trading, and what have you. So they use them, and If these big guys are using these big guns and we are able to lay our hands on some of them, why don't we take advantage of that? Okay, so as I said, if you have a question, it doesn't have to wait, okay, till the end of the presentation. You can just click on the right hand button and you can ask your question. All right. Okay. So trading bot building framework. Here we will see the step-by-step, okay, process that is followed when building a bot that will trade. As I said, the idea is to build these bots, automate them so that they will be doing our trades on our behalf without us having to be the ones executing things manually. So we will see the framework. For those who have attended the previous sessions, you know of the framework, just that we will have some few things added today. In terms of tools, when you are building anything, you require tools, and the tools we are going to use include ChatGPT Plus. Okay, I've switched from Google Bard because ChatGPT Plus is more accurate, and for the sake of time, I do not want to be haggling with Google Bard correcting errors. With ChatGPT Plus, I can be able to get my course running the first time. Google Colab is the Python environment, Python libraries, okay, and Alpaca API. These are the 4 tools we're going to use. With the ChatGPT Plus, what we intend to do is to give it a well-described, definition of our strategy. And what we want from its end is to give us the strategy in code that we can run. Okay. For the case of Google Colab, is so that we can use the code generated by ChatGPT to run it and see how our strategy is faring. And not only that, to connect to the market, it is also free. Unlike the ChatGPT Plus, of course. ChatGPT Plus, you need to pay. All right. Pandas, NumPy, Matplot library, Y-Finance, CA-Lib, Scikit-learn, TensorFlow, PyTorch, OpenAI. These are Python libraries that allow us to build our trading bots. Okay. Python has different libraries that were developed by other software engineers and developers so that they make life easy for others. So if I already do something and I know this is something that many people will be using, so instead of me to allow and just use my code alone, I can package it into a simple library and give it and share it with other people so that people don't have to be coding everything from scratch. Okay, so these are the libraries we're going to use. Some of them, for example, Scikit-learn, TensorFlow, PyTorch for machine learning, NumPy, Pandas for data processing and analyzation, Matplot library for visualization, Y-Finance for getting market data, TA library for technical analysis, OpenAI for reinforcement learning as well as natural language processing. The last tool is the Alpaca API. So this Alpaca API provides us access to the market. It gives us the interface between our code and the market. So we need this. Otherwise, whatever we develop, all our codes are going to be locally deployed in our computers, not going to be connected to the market. So what's the point, But what we want is to have something that can be able to execute trades in the real market, and that's what Alpaca API brings to the table. All right, so as you will see, we're going to have 3 things that we're going to build. Okay, now that we know the tools to build, then what are we building? Okay, what are the parts? And these are the components which we are going to build. First of all, a trading bot is expected to have a signal part or a signal component, then also the order component, as well as the risk management component. The signal component is the most important one. This is the part that indicates a trading opportunity is identified. Okay, so if we have a trading opportunity, we want to buy, right? We want to buy. So without identifying a trading opportunity, there is even no trade in the first place. So this part is the most essential part, is the most important part. The second part is the order type. So once we identify the opportunity, are we going to buy immediately? Are we going to wait? If we are going to wait, what are we waiting for? Okay, are we waiting for the price to come down? That is a limit order. Or are we waiting for the price to go up towards that price so that we can confirm that our predictions are right? That's the stop order. The market order means we just want to buy the moment we have our trading opportunity identified. Lastly, the risk management. Some people don't place this, but we always need to do this. Okay, we need to tell it, okay, if I have $100,000, how much am I willing to invest? Okay, in this trading opportunity. Should I go and put all my life savings in crypto? Is that a good idea? All right. So this is the point. So, or maybe 50%. So that's position silence. What the percentage of your total account balance are you willing to invest in that particular trade? Take profit is saying that if I'm in the trade I already bought in, when should I get out? Should I wait forever, without ever getting out? Maybe I leave it for my grandchildren to inherit. Oh no, I'm expecting once the price reaches a certain value, I will just take my profit, I'll go and enjoy and party and whatever. Stop loss, this is saying like, if I buy something, should I wait and allow my money to go down the drain if I was wrong in my predictions that this asset I bought is terrible? Maybe a friend gave me an advice to buy some coin. Who knows the name of the coin? Maybe Lion coin. Yeah, I like Lion King, so maybe I can also make a coin Lion King and then advise people to buy. So should I just buy Lion King coin and wait till I lose the whole money? Or no, once Lion King, the price of Lion King drops to 50% of its original value, which I bought, I will just take my 50% loss and go. So that's the stop loss. So we need to make this in place. Okay. So now, as I said, we are going to look at how we will build these components and where AI is going to play its part. For the signal part, which is the most important part, that is identifying Identifying an opportunity, we intend to use the regression analysis. Okay. Why regression analysis? As I said earlier, regression analysis is a supervised learning approach. Where we require 1, a historical data, and 2, a label or a target. This is the same thing as predicting a house price. Okay. So this is a tool that is used for this, and it tries to figure out the relationship between independent variables with a dependent variable. Okay. Those independent variables, we call them sometimes explanatory variables or features or characteristics or attributes, depending on which field you're coming from. Okay. So we're going to use this tool. This is the type of machine learning we are going to use. But then we need to understand that regression analysis comes in 2 shapes. There is what we call the simple linear regression, and then there is what is called the multiple regression. Okay. The simple linear regression is talking about the situation where our prediction is only dependent on one single variable. As I made mention earlier, the house price is only a function of the number of rooms the house has. If we only have this as a criteria to determine the house price, number of rooms, then we call this a simple linear regression. And it is considered linear if the house price is increasing with an increasing number of rooms. So the more rooms we have, the more the price of the house. So this is called simple linear regression. That's where the simple comes from, only one variable. Linear means it increases with increasing, and regression is with the fact that we are predicting a continuous value. Multiple regression. Here, we are saying, we have 2 or more independent variables that determine the value. Okay. So house price maybe could be a function of different things, not just the size of the house, but also maybe the city where the house is located, the crime rate of the neighborhood, all right, the age of the house. So all this will come into play for us to be able to actually make good prediction about the value of that house. So in this case, we call this kind of problem a multiple regression problem. All right. So as I was saying earlier, we have different types of relationships. Relationships could be linear, or they could be non-linear, or there could be no relationship between two variables. For example, if you have a variable, let's say the price of a house, as we said earlier, okay, with let's say inflation rate, okay. So yeah, so if for example you increase the inflation rate, so what happens? People don't normally, they want to save money, right? So there is no much liquidity, for example, in the market, because people are saving money. They are getting more, more from the investment. So for that reason, since they are getting more from their savings, so that means that could be an alternative to buying a real estate. That means the real estate might slow down, might fall. So we can assume that could be the case, that if you increase the interest rate, then the house price might reduce. So this is an inverse relationship. I'm just saying, I'm giving a hypothetical example here. But in the case of, let's say, a linear relationship, it's like I mentioned earlier, the size and the price of the house. So they are linearly related. The bigger the house, if we have two houses in the same neighborhood, okay, built the same year, using the same materials, then we are expecting that the house, with the bigger size will cost more. All this is called a linear relationship. So normally you can plot it out and see if you can see a linear relationship, okay? Non-linear relationship could be different. There is a relationship, but it is not linear. For example, as I was saying, even the function between the number of rooms and number of houses is not directly linear. For example, if I said a one bedroom house is going to cost, let's say, $5,000, then a 2-bedroom house is going to cost $10,000. That doesn't mean this is going to be the multiplier factor forever. Like a 100-room house will cost now 500,000. No, of course, maybe the more you increase the number of houses, the less the price becomes. The number of rooms, sorry, the less the price becomes. Of course, yeah, 500 rooms will be a little bit more expensive than 490, but a little bit more. The difference will not be as much when you compare in percentage between a 2-bedroom and a 1-bedroom. No relationship. This is where two things have no relationship at all. There is no relationship between the success of, let's say, an actor and the real estate market. So if an actor won an Oscar, that doesn't mean the real estate in my place is going to go up or down. So the number of Oscars, let's say Leonardo DiCaprio win in the future, has nothing to do with the real estate in the UAE. This is for example. So this is the situation where we have no relationship. And this is how you normally see our data, the historical data. For some of us who have used Excel, you will normally see things in rows and columns, where the columns are the features. Okay, we have one feature here called house age. We have another feature here called square feet. All right, and then the prediction or the target. This is what we are targeting to predict what is called the market value, which is the price of the house. So here, the market value is a function of both the house age and the square feet. So maybe if you are somebody, you can assume that a 32-year-old house should be more expensive than the 33-year-old house, and you can see that from the market value 32 and 33. But the question comes now, if I have a 33-year-old house, all of them 33, but one is bigger, then the one that is bigger will be more expensive. This is 33-year-old, this is 33-year-old, but this one is bigger than this, therefore this one is more expensive. All right, so at least as a human being, I can be able to see this pattern between these two features and the target value. But the problem comes when you increase the number of features. Let's add 5 more, then it becomes difficult for me to figure it out. But it's not difficult for these tools, for these AI tools to figure this out. They will be able to figure out the pattern. Okay, just give them data, give them more. If they are not doing well, add more data. So give them more, they will figure out the pattern eventually. All right, so this is how we will see how to do it. Okay, the other type, how do we intend to do the order. As I said earlier, we have two things, right? We have our order type. But before here, I will first of all talk a little bit about how I intend to go into the trade. Okay, my signal, for example. The order type, of course, I'm going to use the market order. Okay, let me write. I'm going to use the market order. So that is to say, the moment I see a trading opportunity, I'm going to buy. Okay. But for my signal, using the linear regression, how do I intend to obtain the signal? So we have two ways of getting into a trade. We have going long, right? We have short selling, going short. Okay. So if I'm going to go long, that means I see an opportunity. Tesla is likely going to increase in price, so I'm going to buy shares of Tesla and go long. But if I see that Tesla, I predicted that it is going to decrease in price, then I am going to go short. I will go and borrow Tesla shares, tell them immediately, get my money, wait till when they go cheap, I go and buy them at a cheaper price, then go and pay it back. I go and give the guy who borrowed me this Tesla stocks, give him back his shares and go away with the difference, which is my profit. Okay, so what we are doing, as I said earlier, let's say you have a linear relationship like this, okay, and this is the Tesla, okay, and we predicted that, let's take one indicator, as I was talking about earlier, inflation rate, for example, okay, and we realized that there is a direct relationship between the price of Tesla and the inflation rate. That is, the higher the inflation rate, the higher the price of Tesla. Just saying. But I think in this case, it should be the reverse, right? Yeah, if inflation rate is high, people don't have enough money, right? Yeah, they might not be able to afford Tesla. So let's do the reverse, okay? So we figure it out. So there have so many points up there of this, guys. These are the points that we were able to model. We saw that when inflation is at this price, at this rate, this is the corresponding price, and we were able to develop this model. So what we want to do now is to see, okay, currently now inflation rate, let's say, is at 7%, okay, and price of Tesla is $200, okay. Then the next day, inflation drops down to, let's say, 5%, okay. We know that if inflation reduces, prices increase. Based on our, let's say, our line, so that the price is going to increase because inflation now is here. It was here before, so now it's here. We can now trace it up, and we see that this is 250. So we know that since they have reduced the inflation has dropped down, the price is going to be 250. So therefore, I'm going to go and buy the Tesla stock because I know the inflation rate today is 5%. So most likely by the end of the day, Tesla is going to become 250. If I buy Tesla now at 200, by the end of the day, of yesterday, then by the end of today, I will be able to make $50 profit. Okay, this is going long. All right. Another thing is, let's say by the end of the day, it becomes 8%. Okay, inflation rate is now 8%. Okay, so yesterday inflation was 7%. Today morning, inflation becomes 8%. So that means if this is 5, let's say this is 7, this is 8. So I know, and this is 7, this is where the current price is. Then I can shift here. This is now the predicted price, right? This is going to be the predicted price, which is $150. Okay, so this is the predicted price, $150. So I can now go to somebody, tell him, you know what, borrow me 10 stocks of Tesla. Okay, I borrow 10 from the broker. Okay, I go and sell this 10 in the market. So I will make 2,000 times 10, which is, okay, 200 times 10, sorry. 200 times 10, that is 2,000, right? So that is $2,000. So I keep this $2,000. By the end of today, it becomes 150. So I go and purchase 10 of those, that is 1,500, and I return them back to the guy. Thereby I made $500 as profit. Okay, so this is going short. So this is how we will do long and short. So we will have our our linear regression curve or line, and we make predictions of the next day price. Okay, so this is how I intend to buy or sell. All right, and when I already buy, let's say I bought Tesla for 200 and I'm expecting it to go to 250, then I see this curve is now starting to drop. Maybe the trend is starting to reverse. Okay, instead of for the price to be increasing since inflation rate has decreased, now the price is starting to increase, and the curve that was like this now is becoming something like this. The slope is not much compared to the yesterday's slope. So I might say, you know what? Let me just take my loss. Now I'm not talking about profit. I just don't want to lose my money. So maybe the price dropped to 150, and that's where I want to sell. So the point is, we are going to monitor the slope. Okay, and the slope, there is a measure called R2 or R squared. Okay, so if this R squared is high, let's say 1.0, that means the slope is very steep. If R squared is 0, that means there is even no relationship between these guys. Okay, so we want a very high R squared, and you can have -1, that means the relationship is inverse. So these two guys are inverse. So this is the R, or the correlation coefficient. So we want to make sure that if we have a very strong correlation coefficient of, let's say, 1, once we see that it has started to drop, let's say to maybe 0 or less than 0, then we just go out. We know the trend is now changing, it's reversing. Okay, so this is how we enter, how we exit the trade. This is our risk management as well. Okay, I hope this strategy is clear, and I explained the risk management from what I just discussed earlier, that we're trying to observe the trend reversal. Okay, once the trend reverses, we sell or we buy, or depends, we get out of the trade. Okay, once we reach our prediction, we sell and go away with our profit. We have the position sizing. We will just, let's say, do 5% of our account size. So whatever our account size is, we are not going to go for more than 5%. Okay, so this is how we are going to manage our risk. All right, I hope this is clear. So the framework, okay, this is the framework I always follow. Before, we had 4 components: building the strategy, testing the strategy, connecting to the market, and then automating the trade. How we automate the trade, right? Make it to become automatic without our involvement. But now I have added 2 more steps here. Why this step is obvious. We are talking about AI now. We are bringing it into the mixture. Therefore, we are going to have the machine learning process embedded inside the original framework. The environment setup is just added so that we start with that. We set up everything that is required, put all the libraries, have all our tools in place before we start the building process. Okay, so what is this machine learning process? The first step is we are going to collect data, and you will see how I will do this. I will start by collecting data, then I will prepare this data. Okay, once I prepare this data, I will choose a model. The model I'm choosing is that I will train this linear regression, okay, model based algorithm. Then I will evaluate the performance. This is like in school, right? When you train the student, you want to test if the student really understood the concepts. If yes, then you go ahead maybe and give him the next part of the class. If he doesn't understand, then you go back and maybe do some tuning. And that's what we're talking about here. You go back and tune for accuracy. So you want to say, okay, maybe let's change something. Maybe the example I was given was too complex or something like that. So this is the machine learning process. Okay, so I will follow this to train my algorithm, my model. All right, so now we are in the bot building live demo. I'm going to now share my screen to start working on this. Okay, are we together? All right. So yeah. One second. Trying to share my screen. Okay. Okay. So yeah, I hope you can see my screen. I splitted it into two so that we can speed up the process and we can be able to see all the process one after the other. Okay. All right. So as I said, we needed three tools, okay, or four tools to be specific. First of all, we need ChatGPT, okay, and then we need Alpaca to connect to the market, okay. Then we need Google Colab for our codes. All right. So the first thing is the first step of our framework is to do an environment setup, and that's what I will start with. And I will start with our tools. The tools we need, the Python libraries that we need. Okay, so we have these guys here. I will install them. I will run them. Okay, it will install these libraries. In the meantime, I can change the name of this. Let me call it demo code. Yeah, 114. Okay. All right. So this is all setting up the environment. I will still wait for it to finish. Okay, I got the tick. All right. So the next thing is I want to test connection. All right. This is the Alpaca API. If you come to Alpaca, you come to the home page, you will normally see this. These are the orders. All these are orders we executed yeah, in the previous sessions. Okay, so this is currently the ones that are still open from all those executions we did previously. Okay, so we have this panel here. Normally, how do we do it if we are going to do it manually? I will come here, I will type Google, for example. I will tell it the type of order. Market means immediately. I will indicate the quantity, or if I have my money, let's say I just want to, I know, let's say I have $1,000. I don't want to do more than, let's say, 50%, right? 5% of my account. So $1,000, 5%, that is $50. Okay. So I will put $50. That is equivalent to 0.36 shares. I said, put it in place. Then I can review and I will say confirm order. Okay, order created. Let's see. Is it there? Yes, this one here, right? Few seconds ago. Okay, so you can see it here. The one that was created, we can open it up. Okay. This is the chart. You can add indicators maybe in the chart that you want to have, moving average, what have you. Okay. Let's say I want to cancel this order. All right, I will just come here. I will click here to cancel. You tell you want to cancel, sure, cancel. So this is doing this manually. Okay. What I want to do now is to do this automatically. That is from my code. From here, I want to do this connection. So this is what I will do. I will come down to ChatGPT and I will tell it some story. Okay. I will tell it something like this. I already have this. So I told it I want to build a trading bot that will trade Google stock. I want to use the Alpaca API to connect to the market. I have installed all necessary library requirements. I'm using a paper trading account to test my strategies. Test the connection. Start by executing a market order on Google. Let the trade run for 10 seconds, then cancel the order. Okay, let's give this guy the code, the prompt. Okay, it will tell us so many things because you can tell it, do not have to explain, just give me the code. Okay, so it is telling you to start by installing Alpaca. I already did that. If you look at it here, click install. Alpaca Trade API is installed, already done. So I don't have to do it again. Okay, so it is giving me all this information, what to do. Okay, now it is finished. I will just copy this code. I will come here, create a new cell, created it here, then I will paste this. But I need to change this API. I think it told me here. Yeah, let's write this. Please replace your API and this one. Do we know how to get this from Alpaca? You go to the home page. Okay, can go down to the trade where you place trades. Do it manually. If you want to do it automatically from your code, you just click this show API keys. You can copy this endpoint. You can copy this key. Okay, this is the key. Come here, I paste it. Okay, then the secret, I already have my secret. So when you generate your secret, make sure you save it in a Word document. Okay, so I will come get my secret. I will come here, I will paste it. Okay, good. So with this, let's see what happened. Okay. All right, so let's run this code. Let's monitor this. You see new order in a few seconds. So now it is going to cancel. Order cancelled successfully. You see here, going to cancel. Let's refresh. Cancelled. You see, cancelled. Okay, there is a little bit of latency, but it shouldn't be a problem. So we started the order. We placed the order from our code, and we have been able to cancel it on Alpaca. So our API is connected successfully. We are happy everything works. Okay. All right. So let's go to the framework. What's the next thing to do? Build the trading strategy. Okay. So here I will have to tell it. I will come back to ChatGPT, and I will tell it some few things. Okay. And what I will tell it is things that are related to my strategy. Okay. So I will come. I will tell it all about my strategy. I can have it already written down. So to save time, I'm gonna go and escape this part. Yeah, let's add this also. All right, so let's see. This is the logic. What have you? Okay, so I will send it. Then we can read it while it is generating the information. Okay, so I said, good. I want to build a strategy that uses linear regression. Remember, we talked about linear regression, and the following are the details of the strategy. The trading bot logic. Okay, it is going to use trend analysis. As I told you earlier, linear regression comes with a line, right? It comes with a line. So we want to follow this trend. If things are improving, we want to follow the trend. So we said analyze the slope of the regression line. A positive slope indicates an upward trend. suggesting long-term growth, while a negative slope indicates a downtrend. The strength of the trend can be gauged by the slope stiffness and the R-squared value, which I told you. This is the metric we obtain to use to know how steep our slope is. So if I'm going long, that is, I see things are going well with Tesla, for example, or with Google. Since we are using Google here, I will stick with Google. I see things are going very well with Google. I want to buy Google. Okay, so that is take long position, meaning that the predicted price I'm predicting now, Google is going to be higher than the current price. Let's say the current price is just 200, and I'm predicting it is going to be 250. So I'm going to buy. Okay. We want to close this position when I reach my take profit. That is when I reach this predicted price, or when the stop loss conditions are met. Okay. And the stop loss, I will indicate to them later what is the take profit and what's the stop loss. If I'm going short, that is I'm selling, I see that Google might not do well. I'm predicting that. Okay, so what's going to happen? So short selling or taking a short position, that is when the predicted price is lower than the current price, indicating an expected drop in the stock price. Okay, what I'm saying here is cover the short position, that is buy back, go and buy, shares to pay back the guys who borrowed you the shares, to take my profit, or stop loss conditions for the short positions when the short are made. Okay. My trading signals. So how do I go into the buy? I already told it I want to do this, guys, right? So first of all, when the line has a positive slope and the current price is near or below the predicted value, which suggests undervaluation. So people are not buying Google at the right price. They are buying it with a cheaper price than it's supposed to be. The sell signal is when the slope is negative or the actual price exceeds the predicted value, okay, indicating overvaluation. The order type, when am I going to buy, now or later? I want to buy immediately once I spot the opportunity. The risk management is just 5% of my account. I want to take profit once the price reaches my predicted price, and I want to implement a trailing stop loss. Okay, I want to make this clear. Trailing stop loss. So as I made mention in the note earlier, I was saying, let's say I put my stop loss at 150. I buy it at 200. If it reaches 150, I sell, I take my $50 loss, I go home. But if you have a trailing stop loss, let's say it is 200 now. Okay, maybe I should write it. Okay, let's say I buy at 200. Okay, then the price now starts to increase to 220. I'm expecting to get out of this trade, okay, at 300, for example, $300. Once the price reaches 300, I'm going to go out. So now the price is now 220, okay. So I can move my stop loss, which was previously at 150. I can shift it up by the $20 increment that was, earned there. So now my stop loss will become increased to 170. Then let's say the price reach up to, let's say, 260. Now I will shift my stop loss plus what, 40, right? So now my stop loss will become 210. So this way I'm not going to lose money. Okay, I'm not going to lose money. At least I have been following along with my stop loss. All right, so that's what I'm trying to do. That's the trailing stop loss. Yeah. So the next thing I want to do now is I want to see the other stocks. Okay. We look at, yeah, so this is the trailing stop loss. We look at rebalancing. So rebalancing is the process where, let's say, at the end of the trade, okay, you want to rebalance and set things in place. Let's say you want to reduce the number of stocks you bought from Tesla and you want to buy more from let's say Apple. You want to buy more from, let's say, Google. Okay, so this you do it every end of the month. At the end of every month you do this. Okay, this is the rebalancing. So you want to do this to manage your risk. And finally, we have what we call the RRR, which is the risk to reward ratio. We don't want to lose more money. If I'm going to put, let's say, 50, I'm willing to lose 50. I'm planning to make at least 100. Okay, that is a risk reward of what, 1 to 2. That is, if I'm willing to lose 50, I want to make 100. Okay. All right. So this is the strategy. Okay, so I told the chatbot that let me know if you understand this before we move to the next step. So it told me, yeah, I understand your strategy using linear regression, and it gives me the some breakdown of everything I told it. Okay, so in summary, this aligns with this, we can move to the next thing. Okay, I'm happy with this. All right, so when I have this, I can tell it, okay, I will tell it I want to now implement this. This is the next step, right? Test. Okay, but before this, we have the machine learning process. Okay, we have machine learning process. Okay, so I will tell it about my machine learning process. Okay, then I will go ahead and start talking about testing the strategy. Okay, so let's go ahead and discuss the machine learning process. Okay, let me copy it down from here. Okay, all right, so I will test this. So I indicate, okay, so to build the trading bot, I'm following these steps and did this. So we have the machine learning process here. I've already told it this. Okay, so I told it the next step is the machine learning process. These are the steps I intend to follow. First of all, I will start with data collection. Then I will do feature engineering. Then I will choose the model, in this case linear regression. After that, I will train the model. I will evaluate the performance of the model, and I will tune the hyperparameters to obtain accurate result. I will run this and it will be able to look at things for me. Okay, let me make sure it understands that. Okay, then I will ask for the code. So it indicated that this is well structured and follows a logical sequence. Awesome, so we get a validation here. All right, I will indicate this now. Okay, so I will tell it. Okay, let's collect the data using using Y finance and pandas. Okay, pandas data frame library. Let's just call it PDR libraries. Okay, Y finance. Finance to get the open. Okay, close. Okay, volume. Let's go. We have low, high. The low price of the day, the high price of the day, the open price of the day. Okay, the close price of the day, and the volume. Okay, of the day. Then we will use two additional technical indicators, SMA. Okay, and the exponential moving average. Okay, then the PDR will give me the inflation rate. Okay, I will combine these features to be predicting the close. Okay, so I will remove the close here because the close price is our target. Okay, the close price. I want the data for the last 3 years. Okay. So it is going to use this. telling me to install these libraries, and it will give me the code. Okay, let me just copy this, paste it while that one is going on. Okay, I want to use this pip install. And this is one thing with the ChatGPT, it's like explaining stuff. Sometimes you have to tell it, give me everything in one single cell. So I will just be copying and pasting as it is generated. Evaluate, train the model, evaluate its performance, and tune its parameters to get the best model. Okay, this is the code. Okay, this one is done. Alright, so it has given us some few things here. Okay, you can see this is the open. We told it we want the open, we want the high, we want the low, we want the volume. Okay, we want the SMA, we want the EMA, exponentially moving average, and then we want the inflation rate, which we got from the pandas data reader. Then what we are predicting is going to be the close. Okay, so this is some example. It just gave us 5 samples of how our data looks like. So now it is giving us the code to do everything. Scikit-learn, I think it's already installed in Google Colab, so I don't need to install it, but just to be sure, you can copy. Remember, if you are using Google Colab, always have this apostrophe sign before you use the pip install. Okay, yeah, requirement already satisfied. Already it's installed. So it is telling us now, copy everything. Okay, use what you have previously and then print this. Okay, so you can copy this, just add the code. Correct your code accordingly, because you can't have negative, right? Okay, let's see. So it is giving some suggestions and modifications in order to make sure we are not getting this issue. So when you see something you do not like, just go ahead and tell it, I don't like this result, looks somehow. Okay, and just give it to the AI. It should be able to handle it for you. Of course, if you already know what the code is all about, you can be able to look at the code, figure out where the logic is not well implemented accurately, and when you have that, just go ahead and correct it yourself. Or you can argue with the chatbot that why are you using this logic, in the code? Why? You should not use this logic. Okay, so I'll run this. Okay, now I got my result back. Yeah, it's still with the negatives. Okay, so we can just keep chatting and arguing with it. Let's assume it worked with us accordingly. So the last step we have tested, not want to connect and automate. See, I will just tell it to do that in one line. Okay, so next I want to connect this strategy to the alpaca. Okay, so alpaca, and I want to use scheduler or cron jobs to automate the trading. Okay, so these are the last steps. You can just put it there. Yeah, here it is assuming 5%. Maybe you were getting some terrible things. Okay, so no problem, you can just work on it, and all you have to do is keep modifying. But the idea is we have tried the machine learning. Tomorrow we are going to see things that have to do with enhancing this strategy, adding some few components to further enhance the output. Okay, all right, so it gives us the example implementation of the trade. Okay, I'm not happy it gave me this. I will tell it write this in full. I can start by copying this one. Alright, so now my scheduler has started. I'm going to be waiting at the end of every day. You can see scheduler started, trading bot is now running. Okay, it is going to run every day to check for what we described. Use this linear regression, make predictions of the price. Once we get good prediction and we see that we get a trading opportunity, we will buy, or we'll go long, or we'll go short, or we buy the current position, we buy some new position, or we sell the current position. It depends. Based on all these results, we're going to be working hopefully without issues. But you need to maybe work more on it, add more things, and that's what we intend to be doing throughout the week. Okay, as I said, questions and answers. If you have any question, you can ask. Okay. All right. So what's next? So this week we are working on machine learning strategy, and we will keep on improving and adding more complexities to our strategies. And the coming week we will work on reinforcement learning. Remember that type of machine learning that works based on trial and error. So we will not have to do the data collection process. So this part is not going to be part of the process. It's just going to be thrown in the out there, and it will be able to learn on the go. Then we will see how we will incorporate natural language processing so that we can be able to read news in the last week of January. How do you get resources of this workshop? From our YouTube channel. We have uploaded all the videos of the last week workshops. They are all there. Okay. Our application too is now ready. You can go to asatacademy.com. Okay, .ai. Sorry, asatacademy.ai. It's ready. You can go there and you can be able to sign in, and you get access to the recordings for free. Our recordings are always going to be uploaded within 24 hours of the workshop or class session. Resources are also made available for you to download for free. Okay. We have premium features, but for now they are also free. You can mute them because we are still working on improving the app. If you need more additional, if you need additional assistance, you can book a free call, 30 minutes, and we can discuss. Can be able to help you set up your environment. If you have a strategy that you like to build, I am happy to help you implement it. If you have a plan of maybe, or if you are a trader and you already have your own strategies, you can implement it. We can brainstorm, we can discuss, and all that matters related to that. Okay, if you want to contact us, you can reach out via any of these methods. And okay, Jen is here, Miss Carter is here. Okay, hello guys, nice to have you here. All right, okay. Have a good day. Bye. Thank you. You are very welcome.